Good afternoon, everyone. I'm Ravi Prakash. I work at Beckn Foundation. I'm a volunteer at the Beckn Open Collective and the genesis author of the Beckn Protocol specification. The next 20 minutes or so, I am going to talk about Beckn Protocol, its open source ecosystem, and its adaptations in various industry sectors. So before we jump right into it, just let's look at some basics. Beckn Protocol is basically an open source specification, right, that when implemented by different platforms, allows any sort of consumer-facing platform to interact or to digitally transact with a provider-facing platform. When I mean transact, I mean a business transaction, like typically like buying and selling. And these transactions are generally decentralized or peer-to-peer, which means that you don't typically require an intermediate platform to sort of match a consumer's I wants to a producer's I haves, right? And that's what this specification is all about. These are just to get a few things right off the bat. These are purely specifications. These are not software. It's not a platform. It's not an application, right? These are just a bunch of specifications. Zero runtime, right? They are completely technology agnostic, which means that you can actually implement these specifications in whatever language that you want. And they're free to use, open source, and they are currently being owned by a large community of volunteers called the Beckn Open Collective. You can find the specifications on GitHub, as you can see. And any sort of network that is created, when multiple platforms implement these specifications, they basically form a network. And such networks are basically called Beckn-enabled networks. Right? So let's jump into just a little deeper and look at the components of the specification itself. The specification essentially consists of 4 components. It consists of a bunch of network actors. It consists of a set of standard APIs, a standard schema, and a communication protocol. So let's look at the network actors, which is the bottommost layer. At the core of any Beckn-enabled network, you'll find 4 actors essentially, right? A Beckn application platform, a Beckn provider platform, a Beckn gateway, and a network registry, right? The Beckn application and the Beckn provider platform together form the transaction layer of the specification. The Beckn gateways and the registries form the infrastructure layer, right? So whenever 2 platforms need to communicate, you require a digital infrastructure in between. The gateways and the registry form those rails, digital rails that allow these communications to happen. Together, they are called Beckn-enabled network. Let's look at the transaction layer of the network. So on the left, we have the Beckn application platforms, right? They typically acquire sort of end consumers as users. They provide, you can sort of think of them as supercharged browsers, providing a very buyer-focused experience, right? They provide a good, rich buying experience, right? They interface with the BPPs and the gateways to do what? They allow their users to discover products and services, place orders, view various status updates, update and cancel orders, allow their users to rate various orders, and also contact support, etc. Typically, whatever happens in in today's e-commerce platforms. But yeah, there's one thing which I wanted to say. All of this, these Beckn application platforms provide without maintaining an active inventory of products and services, right? That's what happens in today's platforms. The platforms that that provide the buying experience also maintain an inventory of products and services. So this sort of unbundles this entire ecosystem of buying and selling into 2 sides, right? On the flip side, there are some examples of the Beckn application platforms. Typical examples of application platforms can be the typical aggregator apps like ClearTrip, Swiggy, PhonePe, etc. Super apps, D2C storefronts like WooCommerce, Magento, etc. Any sort of consumer-facing chat bot experience like Telegram bots. Content websites like TripAdvisor, food blogs, travel blogs, etc. Affiliate marketing widgets. Today, affiliate marketing widgets offer an experience where you click on something and you get redirected to a particular platform. Using this, if that affiliate marketing widget was a BAP, you would be able to do the entire buying experience itself on that widget, right? So that's the sort of power that this protocol enables. Other things could be hardware utilities, IoT devices like home automation systems, fitness bands, pacemakers, etc., and phone helplines, right? Like 10218, etc. On the other side, we have Beckn provider platforms, right? They do the exact opposite of what a Beckn application platform does. They acquire businesses as the users, and they provide this a good selling experience, right, for their users, right? They actually maintain an active inventory, they maintain an active, database of orders, etc. And they interface with the BAPs and the gateways to, publish their catalog of products and services, provide the ordering terms, the terms of service, terms of payment, etc. They publish, they receive orders for various products and services, provide status updates, provide tracking information to allow the BAPs to track their orders, accept ratings, not rating of just an order, but rating of whatever service that they can provide. You can actually rate the quality of customer support, rate the quality of an order, rate the quality of installation, whatever, right? And also provide the information required by BAPs to contact the customer support of your business. So those are backend provider platform. Typical examples could be the backends of aggregator apps like Redbus, Swiggy, etc. D2C storefront backends, like the Magento admin panel that you can see is typically, you can consider that as a BPP application. Business owner facing sort of chatbots like today, in remote cities, remote villages and all, buying and selling still happens through WhatsApp. I contact my local kirana shop owner and say, okay, bhaiya, is this there? That guy says, yes, I have this, right? A typical buying and selling can actually happen through WhatsApp. To think of those kind of experiences as BPPs, point of sale systems that are, typically present inside the shop of an owner, right? Those are, the things that are, can be considered as BPPs. Moving down a layer, the gateways form part of the infrastructure layer of a network, right? They interface with BAPs and BPPs to enable only one small thing, right? They allow discovery of platforms on the network. They sort of act as a very lightweight utility player to broadcast all the search requests that they are received from the BAPs and forward all the sort of responses, right, that you are receiving from BPPs back to the BAPs. It sort of acts as a agent for democratizing search that allows an equal opportunity for providers to get discovered by by various BAPs that are out there. The registry forms the fourth component of the specification. It also is part of the infrastructure layer. It sort of allows permissioned onboarding of various platforms on the network through a formal certification and compliance process. The certification can be strict, it can be lenient depending upon the kind of network that you want to run and orchestrate. They interface with all BAPs, BPPs and BGs. They allow authenticated lookup of various platforms that are there on the network, or the trusted platforms that are there on the network. It acts as a public key infrastructure to store the various public keys to allow these transactions between BAPs and BPPs to be sort of digitally signed and digitally verified, right? And it also allows us like sort of a high level search filtering based on industry, sector, country and city. Like for example, could be, get me all the platforms on the network that offer transport services in the city of Bangalore in the country of India, right? So sort of like a high level filtering of, platforms, so that just to optimize search. So these are the four components of the protocol. Now let's look at what APIs power these transactions, right? So what we have observed over here is that any consumer provider interaction can be broken down into a set of 10 request callback API pairs, right? Any consumer provider transaction can also be broken down into 4 stages of discovery, order, fulfillment and post fulfillment, right? Discovery contains APIs to discover products, services, businesses out there. Ordering allows you to fetch quotes, get the terms of service, actually provide proof of payment and sort of confirm your orders, right? And fulfillment, once the order has been created, these fulfillment APIs allow various tracking of various fulfillment updates, order updates, and cancellation of those orders, tracking, etc. And once the order has been fulfilled, the post-fulfillment APIs allow any application BAP to rate the BPP's entities and also contact support, etc. Right? So couple of more things. These APIs are all server to server, which means that the experience layer over here, which is the application, is completely left to the implementer on how he wants to orchestrate all of these experiences, right? You can have like a search API fired, getting a catalog, showing it, while internally firing other APIs, connecting to other networks, trying to optimize that search, providing a better service. A typical example that I give is that you can sort of, using Beckn protocol, you can order a cab, order a coffee, and get a logistics person to pick up that coffee from that coffee store, get it delivered on the way in your cab, right? So all of these, given all of these platforms are suddenly on standard APIs, you can now, it's up to your imagination to orchestrate all of these APIs to create the best experience that you want to provide, right? And the API documentation is available on GitHub. Please feel free to go through them and comment. Then let's now look at the schema that typically is used, that defines the data structure that flows within each of these APIs. So Beckn sort of defines an abstracted schema. It's inspired from a lot of open source schemas out there like schema.org, etc. It sort of defines an abstracted schema to represent the core, sort of fundamental, components of any transaction, right? Like typically like, a search intent, a catalog, orders, and contents. It defines these top level schemas to, which are composed of, mid-level schemas like, provider, fulfillment, offers, etc., which are again composed of lower level schema, and so on and so forth. We also use certain, global standards like ISO and RFC 3339 for date time formats, etc., which are sort of generally globally accepted as standards in the specification. So these APIs with the schema allow, when implemented, allow any buyer and seller to sort of, application platform to transact with each other. The fourth layer is the communication protocol. Once implemented, the protocol also specifies 3 types of communication interactions between platforms. There's a broadcast interaction where if I want to find out what are all the platforms that are there on the network, I can do a search broadcast. That's one type of, communication. There is a typical request callback specification. All these APIs are asynchronous. This was specifically done to sort of emulate real world behavior, because like say if you're booking a hotel, you're not expecting a confirmation. Sometimes you don't get a confirmation immediately, right? You might get a confirmation 3 days later. So these APIs were designed to sort of emulate the fundamental behavior of producer and consumers, which is fundamentally asynchronous actually. So third is unsolicited callbacks. This is which basically doesn't require a BAP to specifically request for information. The BPPs can actually send information asynchronously back to the BAP. This is especially useful when you are sending order updates, status updates. Driver has picked up your order, driver has left the building, driver is almost there. Those kind of status updates. Sometimes the order gets cancelled at the seller's side. So auto cancellations, auto updates, etc. can be supported using unsolicited callbacks. So these 3 are the kind of interactions that typically happen using Beckn protocol. So so I think this was all theory. So let's look at the open source community of Beckn protocol and the ecosystem that it's currently evolving, and the various projects that are there in Beckn, right? So these are some of the open source projects that are currently being maintained in the official account of Beckn. So as you can see, these projects are quite diverse. You can, you see projects ranging in across various industry sectors like retail, mobility, healthcare, even education and skilling. As actually it's not there, but over here, but there is currently a network which is being built for education and skilling. And there are applications for searching jobs, connecting to various scholarship providers, etc. And then across application, there are various technologies that are currently being implemented. There's a blockchain-enabled applications that can connect to blockchain, and there are plugins, utilities, and SDKs to allow various interactions to happen faster. There is a formal process of evolution of the Beckn protocol. This is basically starts off with discussions on GitHub, moving to issues, turning into proposals, protocol graphs, and finally reaching protocol standards. All of them are sort of guided by design principles and a strong governance model. And there are working groups that manage the evolution of Beckn protocol and its adaptations in various sectors to sort of enable these smooth. And these are all part of the larger community of Beckn. There are people who have broken off into small working groups to sort of manage the evolution in various sectors. And and these working groups sort of support these adoptions of Beckn protocol in various sectors, like the Kochi Open Mobility Network, which was the first network that was created using Beckn protocol in the domain of mobility. It allows various applications to connect with various transport service providers like ferries, metros, and cab agencies to sort of via standard APIs to allow, various, the Stay Hello application is a chat-based application, and the Yatri is a typical, mobility application. Both of them are providing their own types of experience to connect with various transport services, right? And the second one is the Open Network for Digital Commerce. I think this has been quite popular nowadays. And this is a larger network it's a nationwide network that allows various consumer platforms to connect with various, retail stores, kirana stores, and, in an interoperable way, and allow buying and selling of retail, food and beverage, and logistics services. And the latest one is the Unified Health Interface, which is an initiative under the Ayushman Bharat Digital Missions. This is currently being managed by National Health Authority that allows any sort of consumer-facing platforms and devices like, phone books or chat applications or 108, 102 helplines, even IoT devices like pacemakers and etc. to connect with various health service providers like, doctors, diagnosticians, pharmacies, blood banks, alternative medicine, wellness centers like, fitness, yoga, etc., insurance providers, etc., on a common network. All these three networks are currently being run on the base transaction layer of Beckn protocol. And all of them, two of them are national missions. One of them is, the mobility one is a city-specific mission. But there are other networks in the domain of, agriculture, skilling, education, and stay and tourism, etc., that are all coming up in the concept setting stage. All of these networks are live, and feel free to check them out online and join and contribute. And the great part is all of these networks have adopted open source and are creating these digital public goods for you to adopt and start contributing to that and transacting and building your own businesses on that. Yeah, that's pretty much it about Beckn protocol and its open source ecosystem. Yeah, and if there are any questions, please feel free to.
What about failures and concurrency? Like, how is that a part of the design of Beckn protocol? Because
can you elaborate a little bit about concurrency? Can you give me an example?
Sure. So let's say, for example, in in ticketing system generally, what happens is, let's say, for example, if you want to book a movie ticket,
yeah,
and I block 2 seats, right?
Yeah.
And if there is a concurrency that is happening by some other BAP, right? So how does that work out?
Concurrencies and requests are usually internally managed by the platform that is offering those services itself. The protocol itself does not offer any concurrency. It just sort of standardizes the way it communicates. The concurrency has to be managed by the implementer of the platform that is offering those products and services.
So, but then they will be able to, like, they will be definitely facing concurrency issues in that case, and they have to take care of the concurrency.
It's very similar to what's happening nowadays. Like, for example, you can book a movie ticket on Book My Show. You can also book a movie ticket on the PVR app, right? Both of them. So PVR application's internal booking system, either it can manage those concurrencies internally, or it can also say, okay, I'm going to allocate this many tickets, that are coming from ONDC. I'm going to allocate this many tickets that are coming from, my own application as well. So it internally, it depends upon the business logic of the service provider to manage those concurrencies internally.
Yeah, that has a different thing because they actually lock the seats. So if you actually lock the seats, the same seats in Book My Show, if you try to go to Paytm, you won't be able to get those seats. You won't be able to do that, yeah. Right, so that's where the concurrency is handled between different applications in ticketing, actually.
Correct. So any booking concurrency is always handled at the service provider level over here. They don't rely on the application that is provided, because think of those applications merely a very glorified like browsers, right? So they don't manage concurrency. It's the application themselves that are providing to internally manage the concurrency between various applications.
Got it. And what about failures like rollbacks, or let's say if I'm going to place an order at this point and I place the order, but because of some concurrency issues by someone else, or probably something
like something cancelled the order,
etc.
So what happens is the platform that internally cancel the order sends an asynchronous callback to the application platform saying, hey, your order has been cancelled, with an error code saying that there has been a your order basically has been cancelled. Typically, that's how it happens. And the application provider has to orchestrate its experience to sort of give the user. This is where your innovation comes in, right? Say, for example, you placed an order for some groceries, right, from a typical kirana store, and typical kirana store receives merchants on his store as well. At the same time, it receives online orders as well. If say some guy comes to the shop, takes that item and goes away, now that's where your application platform's experience innovation starts coming in. Internally, it doesn't even have to inform the user that your order has been cancelled. It just has to probably inform that, hey, your order is coming from a different store. It internally files another search, does a select, and confirms an order, updates the order, and also books a sort of a logistics agent to pick it up from a different store, or and deliver it to them. So that's how it typically works. It's actually happening on ONDC right now.
Okay, and one last question before I give it. Like, how do we, like, at least for me, how do I get started with ONDC? If like.
Okay. So I think ONDC is something which you will probably have to connect with them on their website itself. I think, and you can also email them. I think it's team@ondc.org. The Beckn Open Collective generally does not do onboarding for ONDCs. It's an open source community over there. But you can join the collective. There are enough members from ONDC that are there on that who can help you out with onboarding.
Got it. Thank you.
So I'm interested in knowing more about the open source part, the registries, the Yatri app, etc. How do you kind of interface with them, and how do you persuade them to keep these registries and these? I mean, the number of bits and pieces to enable the ecosystem are it's quite a sizable number.
Right. So I think I would want to sort of probably take a step back over here and break this into two parts. One is building the components of the ecosystem, right? And the second thing is the open source nature of it, right? Now, the foundation itself, the Beckn Foundation, also enables a lot of developers to build open source projects so that other people can adopt and implement. But it doesn't mandate that the products that will be built on Beckn protocol will always be open source, because there will be businesses that would want to build. So the building blocks of those implementations, right, is generally encouraged to keep it open source. Like, for example, if somebody is building the foundation is right now maintaining a project called the protocol server, right? That is basically an SDK that, if when implemented inside your own cloud, that makes you Beckn enabled immediately without needing to worry about schema compliance and signature validation, etc. And those kind of projects will obviously continuously always be supported by the foundation and the open source community to sort of accelerate adoption. Interestingly, these networks like ONDC and UHI have also started adopting adopting these open source mindset very seriously, and have started building these building blocks. Like NHA has had a hackathon recently. They open sourced a complete doctor side application and a patient side application so that the participants can focus more on innovation rather than building these things from scratch. So I think it's happening. I think, but it's completely left to the adopters of the specification whether you want to open source things or not. But yeah, I think from the collective point of view, like in the Beckn Open Collective, like we typically one of the community guidelines is that if you are showcasing any product on the Beckn Open Collective Discord server or any of the working group calls, it has to be open source. Right. So I think that's something which we very strongly sort of encourage, and we sort of mandate that it's not a marketing platform to market your products. If you're marketing your products over there, it has to be open source. So that's kind of the guidelines that we follow by.